Okay, what is up guys? I am working on this Asus laptop. This is a customer laptop. It's from Toyota, and the model is it's a Asus S532F. Let's over there. Just give me a moment. Yeah. Okay. So yeah, I wouldn't have recorded this, but anyways, I will do it because the previous videos people were complaining about the sound, background sound, saying it wasn't clear enough. Anyways, so a typical circuit of a laptop looks something like this. Let me just grab a sticky note. Okay, let me zoom out. It should be good like this. Okay, so from your charger like this should be a positive, this should be a negative. So you've got your charger like that. Typically you get a fuse. We can name that fuse 1, or sometimes they put an inductor there. We can name that L1. So I'm sure you know fuse is represented by F, inductors by L. So this is meant to protect the circuit if there is anything that happens, so that it doesn't burn. Anyways, from there usually we will move to the first MOSFET, which will be over there, then the second MOSFET over there, and then we will get our current sense resistor, which we will name R1. Then now we have got our main power rail. So this should be MOSFET 1, which is Q1, which is Q1, and this should be MOSFET number 2, which is Q2. So you get your fuse or inductor depending on what the manufacturer wants. You get your first MOSFET, your second MOSFET, and you get your main your resistor, current sense resistor, then the main power. So right over here you've got your controller, which you will name U1. So usually for most models it's usually the PQIC. So this usually has got a controller controlling these two MOSFETs going to the gate. So this our ground becomes the same ground that goes to the rest of the machine. So you find that this controller also has got ground to it. And then right from here, either from before the fuse or even after the fuse, you've got power coming to the controller there. So the controller needs to receive power from the charger so that it can be able to switch on these two MOSFETs. So you get it. So without the controller receiving power, these two are dead, they're not working. Anyways, here you'll be getting something like 25 volts, similar here, 25 volts, and then you've got your output 19.5 volts. So we'll assume this was also 19.5 volts. So these, they do not step up or step down any voltage, they just allow it to go through, but then they are acting as switches, so they're being controlled by this controller. Anyways, so because of this, if the controller detects that one of these two is dead, it will switch off the remaining working one. That's how it typically works. So there is a lot of other cables. So for example, there is another cable which comes here by the current sense resistor. I've made a video about this. It was a T460S where one of these two was broken and the controller switched off everything. Reason, it wouldn't charge. Reason being, it couldn't tell how much power was being drawn by the machine. So it will read the current just before the resistor and after the resistor, and then that information it will tell the controller how much the machine is drawing from the charger. So once it fails to detect that, it stops charging. So anyways, in this case we're going to check the issue here. to see if we've got our main power rail. So if I plug a charger now, here is the machine. So if you look here, we've got our charger, and from our charger we've got our inductor. So they put 3 actually. This is a capacitor, you can see it there. Then there's 3, 1, 2, 3. They are connected together, and then that's an output. So then you get your first MOSFET, your second MOSFET, and then you've got your current sense resistor. So to make it correspond, charging port, that's this side. We've got our inductors, that's here. We've got our first MOSFET, Q1, second MOSFET, Q2, current sense resistor, and then this controller U1, I'm gonna try to locate it on the motherboard. Let's hope it's on the top side of the board. I don't see it, so it's probably at the back. Anyways, we're not gonna bother about that. I'm gonna plug a charger for now, and then we can see if we are getting any response to the charger. I'm gonna put the DC power supply to 19.5 volts there. Plug it in. Oh, need a smaller tip, smaller than this. Okay, so there wasn't any response to me plugging the. Okay, I'm gonna try to accommodate the multimeter there. Okay, so our ground probe to ground, our positive there to positive, we've got 19.6 volts coming in. By the inductors on the output, we've got 19.6 volts coming in. But this side, we are getting 3.2 volts. And on our main power rail, we're getting 3.2 volts. So we've got an issue of no main power rail. So I will check if we've got a short, which we do not have because we're getting 3.2 volts anyways. So you can see there's no short circuit on the main power rail. There is nothing on the main power rail. So you check the main power rail from the current sense resistor here. That's your main power rail location. So when I check it over there, there is no short. So now what I'll do is I'll check the 2 MOSFETs to see if there is an issue there. And this one is fine. And if I check with this, we've got a dead MOSFET. So this guy is dead over here, which means we have to replace that. And hopefully we've got our issue solved. Grab the MOSFET from this motherboard. So from here we've got our charging port, first, second MOSFET. So I'll remove this guy from here. Okay, there we go. From here, before I can take anything off from there, this is what I'm gonna do. I'm gonna add some Kapton tape. I can do it without the Kapton tape already, but just to keep things safe, this is an SSD connector. We do not want to risk it. So the Kapton tape is gonna protect this connector from the heat that's coming from the hot air. and I'm working on this. Okay, be on the side there. Now we can attempt to lift the MOSFET. Okay, MOSFET is off. I noticed it was out of focus there. Anyways, I'm gonna put the second MOSFET in now and try not to lose that focus. I've reduced the airflow there. Always harder to do it with when you're recording compared to when you're not. If I wasn't recording, I would have long finished this repair. Okay, there we go. I believe the MOSFET is sitting properly. Let's pull out and test the charger now. Do you have any response? Okay, we've got our 19.7, getting 4 volts over there instead of 19 volts. So probably the MOSFET that I put is also dead or is not sitting properly. What does it? Let me just check to make sure that it's sitting properly. Because the angle I was applying heat from was kind of awkward. Okay. Okay, there we go. Let me try to check again. If not, then I'll have to change that MOSFET, because it could be an N MOSFET replaced for a P MOSFET. Then yeah, that will not work. So we still don't have a response to this. So I'm gonna grab another MOSFET and test it out. One that I know is working. It's this one here from this Lenovo motherboard. So I'll just grab the MOSFET and then replace it again. Okay, here is a non-working MOSFET to be replaced onto this motherboard. I think you can see the red reflection of the element inside this nozzle. Just to give you it's just there, you can see it there. It's turning red. That's how hot this thing is. And if it happens to barbecue your skin, yeah, you feel it. It's a scar that you will remember forever. There we go. So I'm just going to add some solder on the edges to make sure that these terminals are connected. I usually don't want to work with flux because it kind of makes the motherboard messy. But anyways, I'll do it now because I don't want to have loose connections there. sure that we're connected. Let's plug a charger, and now we have a response. And you can see an orange LED over there. And the motherboard is now drawing some current, and the fan is spinning. Yeah. So it simply means I had replaced with the dead MOSFET. Yeah, it happens. Anyways, let me open it up so that we can have a picture. Let's hope we have picture. As Sorin always says, wait for it. Okay, it's jumping around on the power supply, so I believe it's gonna power on. As I patiently wait. We have picture. Okay, there we go. Asus in search of incredible. So one of the guys on the Discord forum once said Asus in search of more money. Yeah, just from the way these things die and fail. So this one is actually an i7 10th generation, so it's still worth repairing. There you go. Asus in search of incredible, and it's now loading Windows. Anyways, I'm gonna just plug the battery to make sure the laptop is charging. Okay, yeah, the laptop is charging, so you can see orange LED there. It's off, it's not spinning the fan, and it's drawing 1.56 amps. I don't mind, my tip is a bit it's not the correct tip, it's for the Nova, so it connects and disconnects. There we go, 1.56 amps, so this is fixed. I hope you guys learned something and enjoyed the video. Anyways, I will see you guys in another repair. Thanks for watching. Cheers guys.